Hey there. I recorded a video earlier to do with some multi-threading issues that, important as they are, I don't know, I might tack some of that on the end of this video. I think of more interest is this RPC server and client thing that I went back and had a look at. What I did was, if you recall from so many years ago, I had this hello and reply. Well, I had a thing called hello, and then added a thing called reply. One was to send a, well, it's not really sending, but to request the execution of a remote process, procedure, I should say. And this reply thing is a thing where, again, it's running a remote procedure. But the procedure, in this case, fills in some data and passes it back. So in a way that one is send and one is receive. And so then what I did was I combined those two things together to make this pair, server and client, that includes the three procs, I guess you'd call it. Well, they're given different names on either side, but for the server, I call this received message proc. Okay. Previously, this was called just message proc, I think. No, not message. What was it called? That would be in hello. Hello, maybe? Proc? Hello proc. Okay, it's called hello proc. A string would come in and then you'd print it out. So thinking of it more in terms of messages, that's like receiving a message, and this is the message, and then I print it out. Okay. Now, the other thing I'm doing, just as a quick hack, is copying that message into a buffer. Okay. So that if the client executes this function, I would then copy the previous message here into this passed in buffer up to the maximum number of characters, and then clear my buffer, and the client would receive that data and print it out. I think the client's proc. Okay, let's see now. Main. Okay, this is the client. Client's main is just going around in a loop until I press escape or something. It's just reading from the console. And if I type in anything but the word shut down or quit, then it here that remote proc thing for receiving a message, I call the send message proc, which it's got a try catch around. So send a string, and so the server at that time would copy that string, and then immediately following that, I invent a 100-character buffer and call the other procedure, which is supposed to copy bytes into my buffer that I pass. This is to a completely different process. And then I print it out if that's successful. Right? Size. Okay. There's a little pack here. If the size is 0, I could call the shutdown. That's what I initially had. Just hacking it together to get anything going. I use that as a flag to say shutdown. Whereas I could check to see if the word is shutdown, right? Because that's what I have up here somewhere. If it's equal to this string shutdown, case insensitive, then here I'm calling the reply proc with 0. 0 and shutdown. Actually, that's a good. That's a less likely accident, right? Anyway, in any case, the point is that it can send and it can receive. What's interesting, though, is the way in which, to me anyway, the way in which these client procedures are carried out. Each of these files has something called RPC. That's the file that was generated, one of the files anyway, generated by the MIDL magic compiler, right? And it was all in that horrible C code. And I tried to clean it up. You look at the server one here. It's not so bad to look at now. These were number defines, and I turned them into. I just put numbers because I find it's no advantage to having a number define here, because for me anyway, when I'm looking at this, I'm more curious about what the relative sizes of these things are. The number define isn't used anywhere else, right? You can always say size of format, so you don't gain anything by it. If you remember previously, as a C file, there was a little bit of a lie going on. First, it would say extern const something or other, and then static down below, right? Because you can't do I don't even know about C++. If you can forward declare a const pointer, right, in a file and not say extern, you make a declaration for a const struct, say, that needs to be visible by some other things, but it's defined down below. I don't know what syntax you would use. If you can't define it here because maybe they need to use these other definitions first or something. Like, okay, this type format strings. I've just defined it as a reference and made it into a function that returns a constant reference to the type format string array, basically. And there's type format and proc format. So there's a language, right, kind of format specifier for types, long, byte, short, whatever, and similarly for procedure type, there's a language for that. And then there are these other kinds of structures. Now here, see, for instance, this dispatch table. Well, this one's not const. It's static, and it's made it into a function that returns a static. I guess it could be constant. Maybe I'm not allowed to try it. This one was different, that's why I had a space here. Probably this can't be constant because it'll be filled with some data, but I don't see why it would be. It's the dispatch table. Okay, yeah, there's not much to it. The functions, all they do is declare a static constant object and then return the pointer or whatever reference. This here, the first number tells you how many functions are in the table, and then there's something here called func table, and it's always the same. Okay, now I think that this stuff is a legacy because all of this is, as you'll see, not only are they all the same calls, but the calls are made in exactly the same way no matter what. It's it's pretty humorous. Okay, now there are 3 procedures, remote procedures. This is the server one I'm looking at, right? So actually these procedures are compiled into this program on the proc. We're just looking at them. Receive proc, get string proc, and shut down. So server routine table. Going back up. That's this. The server routine table just lists the procedures. It's nothing really, not rocket science. This here interface structure, let's see. It's just whatever. It's a bunch of information about the calls. And this here is a fake. This is not a handle, but it's declared as a handle, even though it's a well-defined structure. Again, I think this is a legacy thing. I tried to make sense of some of these numbers and flags, but I'm not sure exactly. The format doesn't matter actually so much, because all you do if you want to create one of these files is you decide on what procedures you want, and then run that MIDL compiler thing. Horrible as it is, it will produce these tables, and you can insert them in. It's quite easy. I was trying to keep these on the side here. Some of these descriptions are really quite informative. Like that's 0, and that's 3 zeros. Very informative. Oops, I should have moved these first. Some of these flags look kind of recognizable. If I can find, some of them look like compiler flags, which is kind of curious and leading. It makes you think that maybe the idea is sometimes that it'll compile something. I don't know. Not important. I didn't fix this up. This is the, okay, now this is the type format string table. There's more than one. So for instance here, this indicates a C string. This is just padding. I don't know what RP is. Something, maybe pointer? Simple pointer, okay, so that's it. But it's not the same. 11, okay, 11 is simple pointer. Don't know about the number, it's probably an offset. A C string is obviously 22, means a C string. 11, pointer, and I don't know about this offset business. C array, so 1B is a character array, right? Not so hard. 0, very informative. 1. I was pretty good at guessing what some of these things were. Like, I don't have my guesses anymore in this file. Here's one that means a character. 2 is a character. 5V terminates the list, I guess. Well, there's another 0. It might be a word value. There's another 1B. 1B character array. Now here's another. Oh no, it's 5C. Not sure. Let's did it backwards again. But the yeah, I'm gonna get to the funny bit in a minute. Just as soon as I get through with the obsessive compulsive bit. Okay. Stub desk. Okay, I don't know. I want to see if it compiles with that const. So it's actually not not that much to look at after you clean it up a bit. I see, it can't be const. Okay, fair enough. Okay, now the server, this particular server, oops, main. What file is that? What is this main? I see, okay. This is called server main. This is a procedure that is run in a separate thread. The real main is here, so this should really be called main. But the other file was main before, and then I made this file and just created a class is a thread, and all its thread proc does is call the server main. And in the main thread, I loop around, making a little spinner go around every so many timer ticks until if I see a request to shut down, then it breaks out and shuts down. The remote client can shut down the server, but the shutting down can't be done can't be done in the thread that services that particular client, it turns out. So it's got to be, it's got to return immediately and just set a signal for somebody else to pick up, like this, which then goes in and runs these magic functions that shut the server down, wait for the thread, which is still on, server main, wait for that to complete, and return true if the thread successfully shut down. I should probably put a timeout here. Milliseconds, 10 seconds. Okay, so there's not much to that. The client, I showed you some of the things that, what it does. What's interesting is the implementation of these calls, okay? Remember, they all take different arguments and parameters and whatnot. Here again is the pared down MIDL, compiler, what it gives. Now, I moved all my projects. So dumb. But its source safe is taking forever to figure out what's going on. That's not where I was. Client here. Okay, I can do that. What did I want to do? Oh yeah, I want to do that. Okay, so a similar kind of jumble of tables and whatnot. And then the procedures, okay. Now, I didn't think this was going to work initially, but looking at this thing here, I always got this, like, they had all this behind macros and things, and there was I think there was something like CS and message or something, right? And it would be this thing, right? And then the address of CSZ message at the end. But then I would get this warning, unreferenced parameter, right? Unreferenced formal parameter for all of them, in fact. But I'm like, it's referenced. I'm using it. What are you talking about? Well, it turns out that this thing is a macro. It's not a function. It takes 3 parameters, the third of which is not referenced. So this again is obviously like a hangover, legacy Z here. What the Z used to be, I think, would have been a VA list, variable argument list, because the real function, this function here, you can see takes a ... right? There's 2 things and then variable arguments following. But look at the way they've gotten around the variable argument list. They take these two parameters, it doesn't even matter if these parameters, you know, you could do this without the two ahead of it. You don't need a parameter. Usually you take like the address of something on the stack, right? But they don't do that. What they do is they just sort of borrow the stack of the calling function. Since this is a send message proc here, it has some stuff that was pushed on the stack, and this is just a macro. So this is being typed here. And then for the third parameter of this call, it says address of return address plus 4. You see? And cast as bytes so that, you know, so it's plus 4 instead of plus 1, you know, if it was D words or something. You know, they could have cast this as D word and say plus 1, D word star. In any event, what's the address of the return address? Not the return address, right? The return address is the position in memory where the call to this function was made, right? Okay, that position, no, sorry, not where it was made, but where it was made plus 5. Now that address is stored on the stack, right? It's stored on the stack at a position EBP plus 4, if I remember correctly. There's call, and then there's one push EBP, move into EBP, ESP, and so on, right? So there's a call which would make the stack pointer initially points at the return address, and then there's another push, and then BP is stored and so on. So EBP plus 4 is the return address. Sorry, yes, it's the address of the return address. If you add 4 to that, remember the stack goes down, then that is the address of the arguments, any arguments that were passed to this function. You see? I just put hello world here because it doesn't matter what you put here. You can put 5. It's always going to come out the same. The reason to put something here at all is because you get a warning if you don't. It says not enough parameters for macro. You'll see in a second. It still works, so you don't have to put anything there. You don't have to reference your stack. See, not enough actual parameters. Doesn't matter. It still works. This one takes a car star. This int and car star. This takes nothing, right? The only difference between these function calls is the index in this here map. This is a map of offset of format string in the format string array. Okay, so we've got these format strings, and at offset 0 is the the information about the first procedures, this one, and there's some parameter stuff, and then at offset 30, is it 30? Or did it change? I may have changed it. No, it's still 30. At 30 is get string proc, and at 66 is the shutdown. So all this They don't use this map. It's funny. The MIDL thing sets up this map of offsets and doesn't use it. It puts the actual numbers in. It makes these three procedures, and instead of making the map, it puts the numbers directly in. So you don't see immediately how they're all the same, right? I was trying to make a general function because I could see it was using a variable argument list type thing, and it wasn't working. But now I've worked it out. See, send is just a macro. ifunc, no, it's got to be a macro because it's got to use that address of return address, right? I guess you could, if it was a function, you would have to find the address of the return address or something. But too complicated. So in a sense, this here call well, it's a pointer. It's a VA list. That's a quick and dirty way to make a VA list, without having to declare anything at all. You just say address of return address +4, and that points at the complete argument list for the current function, right? The fact that there are some other things pushed on before that doesn't matter. So the implementation is exactly the same. It's just a matter of putting the offset in. I thought that was kind of cool. Now I can run it and show you the running. So here's the server spinning. As a client, I can type stuff in. Hello. Okay. This is a thing. There are no arguments to the call. So let me see, it works fine. Now the message here is returning blah blah blah, and the second line that I'm printing out is what I received back from the server. I could, if I wanted, have this thing prompt me, server guy, to enter a response. You have a chat client going, and then if I do shut down, it shuts down the server, exits this, and I added this pressing key, so it wouldn't just disappear. I thought that was kind of cool. Now, so you can send and receive strings. Okay. Doesn't sound like much, but in fact that covers everything. If you can do that, you can do every single possible thing that your mind can come up with. Because a string is information, and a string can be turned into a binary struct, right? You just use that dumb base 64 encoding scheme, right? Something like that. I have a TS string. So if you can send a buffer of arbitrary size, binary data in two directions, then you could use this code to implement function calls either remotely or in a different process or a different machine or whatever. And that's exactly what happened with COM. The idea with COM, the COM protocol for function calling uses a kind of marshalling technique, similar to what we did with that. What I did with that. What was it called? That little paint thing. The thing that drew the GIF files. Pick view. There was a project somewhere on here. I've rearranged everything. Pick view. What I've done is you see how clean everything is now? There's only actually 1, 2, 3, 4 directories. View tests now that breaks up into console, DLL, or Windows. I think the pick view is in here. No, must have been Windows. Where did I put pick view? It's not there. Well, maybe it wasn't a U-test. Maybe I didn't consider it unit test, but more of a unit build. Oh, there it is. It might complain. Pick view used a marshalling technique to call functions synchronously in a different thread. In this case, I have this mode 13 put s, which use this macro marshal to call, which would send a Windows message. With the value being a pointer. The pointer is a struct that contains the information about the call that I want executed in the remote thread. Okay, now this is a thing that has virtual functions that it can be any function we don't know. There's just a function that when the other thread picks up a pointer to one of these things in its message queue, it just calls the invoke function and the result function and stores that somewhere. There's a return value. Okay. So the thing that gets returned from send message is the L result in that structure, I guess. Wherever it went. Marshall, let's go this one. This here. So it's synchronous. Synchronous function calls to do things like plot a pixel, draw a box or something, show GIF, right? And it would get more and more complicated, but whatever. COM calls can either be inter-process or or same process, or even same thread, or well, usually they're never the same. The calls are never executed, I don't think, in the same thread. No, that's not true. That's not true. In the simple case that we looked at, the calls were executed directly There's a direct function call. If it's like DirectX or something, then the calls are marshaled and run in a different thread, right? But to you, it appears as though you're calling functions directly. Speaking of COM, one of the things I was fiddling with the real numbers and complex number things, I made a class to demonstrate how you can make something that uses one of these devices, which are just like COM objects, in a completely seamless way, just as the ATL wizard code does. This is an example of such a thing. Real. If I run this program up to here, all of the work, loading the device, setting up reference counters and so on, it all happens on the first line here. If I put this on output, let's see it more clearly. So I just step over this line. Locals. Okay, so yeah, this got set equal to pi, but in the meantime, that DLL was loaded, right, into memory, and a whole bunch of things happened that we didn't see. And on the second call, it'll just be very quick. That's why sometimes there's a delay in when you're dealing with COM, right? What one line might look pretty innocent, but a lot of stuff could be going on in that one call. Now, this class is using exclusively the DLL for the operations defined here. All of these are user-defined custom operators. Okay. These are all based on these ones. As you can see, this makes a copy of one of the current object and then runs the self-modifying operator and returns the result. That way it can make const. So that also tests the reference counting mechanism. These things each have like a handle to the mathematics object. Okay, so my real math, which is a TS device and currently has 3 references. There are 3 because I've got 2 reals and there's one global handle that was just got constructed on the first declaration and stays around even if these 2 go out of scope. This will hold on to one more reference so that so the library doesn't get unloaded. You need that, in fact, with most of these things, because you could imagine if it were a loop, let's say, and with one of these declared in a loop, you wouldn't want the library to get reloaded every time through the loop, right? So it's good to have one reference that's permanent and everything else copies from that. Well, it turns out one of the things I was always curious about was that precedence order for user-defined operators, times, plus, minus, divide. And it turns out that the precedence order is actually preserved. visual demonstration. This is the second line is always the expected result, and the third line is the what would be the result if or a precedence order was just left to right. And here this line and this line, you'll notice, are identical except for the times and plus being interchanged, right? And the answer comes out to what it's supposed to be. Instead of doing this operation first and then multiplying by that, it does the one with the right precedence order. I could change I could violate the precedence rule by simply making my plus operator do times, right? And then I would have a different math where plus acts like times and vice versa. But whatever, it doesn't matter. And then here I'm checking for them all. You'll notice actually, I don't know if it's still there. Here's the reference count for the global object. Great big line there. I didn't write that in myself. I just dragged the thing. But as it's doing these comparisons and making more and more temporaries, this number goes up, I think up to 11 or something. We'll see that what happens when the call finally. Oh, that was it. We were in the library. Next one. See, it's up to 4. Here we are. Okay, now we're actually in the my real math, VLL. So there's none of this stuff going on in the class. You could imagine the kind of, well, I can anyway, advantages to being able to do something like this with arithmetic, especially with floating point arithmetic. If you wanted to, you could swap out this DLL for one maybe that uses the software floating point logic, or one that uses a package that you downloaded from the internet that does double precision arithmetic. Maybe you could compare speeds, or you can keep account of how many operations are like a profiler. You can profile all of the arithmetic actions that occur in some calculation, let's say, and maybe optimize on that basis. So you see this count is going up and up and up, but it's not using any more memory, it's just incrementing the reference count. God, I wanted to get back to the main. There. But if I jump all the way to here, you see it's gone back to 3. And the fact that it ended up here shows that the precedence rules are preserved for user-defined operators, just like regular operators. And the other thing to test is the comparison operators. equals, not equals, greater than, less than, and so on. If you're curious, I can just run it like this. You can see that, these are all working properly. And I would say that if the example, that ATL example was seamless and requiring very little effort on the part of the programmer, well, I don't think you can get much more seamless than this, right? You simply declare an object and start using it. You don't have to set up anything. I've included this class in my header file, right? And that's it. All the linking and everything is done on the basis of whether or not this thing is null. If it's null, then it gets created further objects, just add more references to this thing. All of the operators called into the DLL. Now for complex math, I'll make another class which will have complex, and if you want to do real math, right, then you'll just, I suppose, one way to do it, or one way to make use of the aggregation would be if you had a complex number and you want to extract, the real number values of either the imaginary or the real part, and do real arithmetic, then you can do that, right? Like for instance, these operators wouldn't be defined for complex numbers, but they are for real numbers. So that might be something that a person would want to be able to do, make comparisons of just the real, the real numbered parts of a complex number. And it all should be just as easy and as seamless as this. So, there's really not the fact that these sorts of things can be done is not rocket science, right? You don't have to be a genius to come up with a scheme that can do this sort of thing with replaceable DLLs and a well-defined interface and so on. I don't know. Okay, I have nothing to add. I might tack something on the end here about threading and thread synchronization that I started on. I got too diverted, and so I quit that out. We'll see. See you.